Okay, so here we are going to talk about Newton's law of cooling, and we have this as a differential equation with capital T being temperature, lowercase t being time. T sub s being a constant, that's not T, it's capital T sub s being a constant for the surrounding temperature, and K being a constant related to, because it's cooling, it's called a specific heat capacity. So K is not actually the specific heat capacity as you would have studied in chemistry, but or in physics even. It is related to that. There, I think there's some proportion in the conversion. So if we want this as an equation, we need to separate our variables. So we're going to start by multiplying both sides by dt. And yes, capital T and lowercase t are different. So we're going to make the capital T's go to the left and the lowercase t's go to the right. So now I've got to move this capital T. The T sub s doesn't actually matter, but we're going to take it with it because it'll be easier. I'm going to divide by T minus T sub s. And I end up with 1 over T minus T sub s dt equals negative K dt. And it's time to integrate. I didn't want that color. I'm going to integrate both sides. And for the sake of this, I'm going to use u as u minus t sub s. du is just 1 dt. The constant goes to 0 and 1t. So I'm integrating here 1 over u du equals negative kt. Nope, just negative k dt. No kt. Giving me ln u and negative kt plus c. Again, I only have to add the c to one side because I can just move it to the other side with subtraction and combine the c's, and we don't know what it is yet anyways, so we can just do it like that. Now I'll substitute back in. We're just going to use parentheses instead of the absolute value here. It's called Newton's law of cooling. If it was warming, it ends up showing up and canceling out on the other side, so it doesn't really matter. Because we're going to change it out of the ln anyways. To get rid of the ln, I'll raise both sides to the power of e. And e to the ln cancels. Okay. And then I'm going to split this. And that's just exponent rules where I take the plus, I add the exponents. Now I need to solve for C. And we're going to plug in T0 for initial temperature. Again, we're leaving it in terms of broad cases. So K times 0 is 0, e to the negative 0 is 1, e to the C. So I end up with this. I'm going to go back to this equation here and plug that in for e to the c. Now I'm going to put it in front because it just looks cleaner. So t minus t sub s equals, I'm right now plugging in, I'm substituting t0 minus t sub s for e to the c into the equation I pulled down. And that is Newton's law of cooling. So I'll write it up above here. Then we're going to solve a problem with it. T minus t sub s. So a hard-boiled egg at 98 degrees, I'm going to label what I know, is degrees Celsius, is put in a pan under running 18 degrees Celsius water to cool. The running water is my surrounding temperature. After 5 minutes, the egg is 38. So now I'll do a different color because this is a case. This is at a given moment in time, we have this case. What it asked me for is how much longer or how long will it take? That's how much longer, but I think they just answer how long does it take to reach 20 degrees. Oh no, they do actually ask how much longer. So my question becomes, let's change color again. So the first thing, I'm going to use the red case. Maybe I'll plug everything in red to get my unknown constant for this egg. I start out at 38 degrees minus surrounding temperature. And this time t is 5. So that's 20 equals 80 e to the negative 5k. I'll divide both sides by 80 and get 20 over 80, which is 1/4. So here, let's do this. Divide by 80. 80s cancel. To get rid of my exponent, I will take the natural log of both sides. The ln of e, it's a little hard to see there, but ln of e to the negative 5k just becomes negative 5k. Ln of 1/4 by the laws of logarithms equals ln1 minus ln4. That's the division rule. ln1 is 0, so I'm just going to change this to negative ln4. You're going to see that a lot. They like to do that in calculus. And then we'll divide by negative 5, making this a positive ln4 all over 5 equals k. Now I need my 20 case, so I'm going to plug that in to the original equation where I don't know time. 20 minus surrounding equals 98 minus 18. That's 80 again. Now I'm plugging in I don't like how that's coming out. We'll write it like that. So this 98 minus 18 is 80 again. 20 minus 18 is 2. So I end up with 1 over 40 equals e to the negative ln 4 over 5 t. I'll ln both sides, which cancels my e. I will make this, just like I did for the negative ln 4 for 1/4, I'll make that negative ln 40. And then I will multiply by my reciprocal. The negatives are going to cancel out and make that a very nice 4. Let's make that neater. And the negatives cancel out, and I get 5 ln 40 over ln 4 equals t. And that, when you stick it into a calculator, is 13.3 minutes. The question actually asked how much longer will it take. So it was originally 5 minutes. That's 8.3 minutes longer. Okay. So now we're going to talk about resistance. And we know the old equation. Force equals mass times acceleration. So this is Newton's second law. Acceleration, actually it's not a capital V, it's a lowercase v, is dv dt, or the derivative of velocity. And resistance, this is going to be a property here, the resistive force is equal to negative k times velocity. Okay, that's just a property that's also known from physics. Might not be one you know, but that's going to be the resistive force that we will use for all the problems like this that we're going to use in this book. So we're going to develop the equation. And again, which equations you'll have to develop, we don't know, but on your IB exam, it will ask you to show this, show that, which sometimes is going to mean develop equations. They're not going to make you do the worst ones or the hardest ones, but they will ask you to do some to show that you know it, not just doing it with your calculator. Time. So we need to separate variables. I'm going to move v's to the right and t's to the left. I'm going to multiply both sides by dt, and I'll divide by v right away. No, just dv. I moved the dt, they canceled. For the sake of ease, we're going to put our two constants together, so I'm going to divide by m2. Giving me negative k over m dt equals 1 over v dv. It is now time to integrate both sides. The left side becomes interesting because k over m is a constant. That's just a constant. So that leaves me with negative k over m t plus c. I'll put the c over there. ln v. I will raise both sides to the power of e. which will get rid of my ln, because ultimately I want v equals not ln v. E to the negative k over m t plus c. I will use my separated out trick. I'm going to put the kt over m, so it's clear that that's on top. E to the c equals v. My initial condition at 0, v of times 0, we're going to call v0. Times 0 over m e to the c. This whole thing is 0, so e to the c is v0, giving me finally this equation. And I guess I just switched the sides. Negative kt over m. So applying this, okay? For a 50 kilogram ice skater, the k in equation 2 is about 2.5 kilograms per second. So I'm going to use this equation. I'm going to scroll down. I'll rewrite it on my screen. So it tells us k. And it gives us a unit. It says, how long will it take the skater to coast from 7 meters per second to 1 meter per second? So if it starts at 7, that's v0. We're looking for the time to get to v of 1. Pretty simple. I'm just going to plug in. Use my equation. Oh, it also did tell me the mass. This is a 50 kilogram skater. I need that. I'll divide both sides by 7 and get 1/7. 2.5 over 50 is negative 0.05 t. Okay. I will ln both sides. Ln, those cancel. And I get ln of 1/7 equals negative 0.05 t. I'll divide both sides by negative 0.05, 7th, or negative 0.05. And that's going to equal 38.9 seconds. That was part A. Now the question becomes, how far will they go? Well, here's the next trick. V is ds dt. So I'm going to take my equation, this guy, I'm going to make v ds dt. I guess I can leave v0 as 7, because I know a few things from this equation, so I'm going to put in my constants. The 2.5 over 50 is this 0.05, so I'm kind of looking at it as this step t. I must separate variables. So I will multiply both sides by dt, giving myself s equals 7 e to the negative 0.05 t dt. No, not s, ds. And it's time to integrate both sides. ds simply becomes s. E to the power of, e to the x is just integral of that, or derivative, is just e to the x. But I have to reverse my chain rule. It's kind of like I'm doing my u substitution. U would be 0.05t, du is negative 0.05 dt, and I got to divide by that. Seven divided by negative 0.05, these two things, is going to be 140. Okay. My plus c here is just tacked on the end. I can assume that s is 0 when t is 0. So to solve for my initial condition, oops, I missed a negative here. There's a negative. Negative 0.05 times 0 is 0. E to the 0 is 1. So I've got 0 equals negative 140 plus c, meaning c is 140. Okay. I'll scroll a little bit, not all the way here. So I have this equation. And I'm looking for how far do they go when they stop? Well, theoretically, you just get slower and slower and slower and slower. And in the theoretical sense, you just keep getting slower, but you never actually stop, which means s is the limit as t approaches infinity. So you're going for an infinite amount of time. Yes, in reality, you can't actually tell that you're moving anymore. But if you just keep having things, or you keep going by quarters or whatever, you never fully get to 0. E to the negative 0.05t. It's going to look like that. Okay. This is going to 0. So as t goes to infinity, that goes to 0. So I'm looking at ultimately negative 140. The e to the negative 0.05t, that's the graph, just goes to 0. Negative 140 times 0 is 0. This is 140 feet. Is it feet? It is meters. The skater will go 140 meters before they fully stop. Okay? And that is section 6.4, differential equations for using, differential equations and applications of them. Again, these are basic applications. You're not going to have to do super complicated applications, but here's some basic ones.